So how can we go from this to this to this? It's not very hard, but it takes a lot of time. And it also involves some crazy charts, which actually worked out pretty well. I'm going to make this handle. So I'm restoring this post drill, and the crank handle I was missing, and so I need to make the bar that the handle will be, but then this will mount to that. And I wanted it to kind of mirror the design of the original, and it's pretty close for a first timer. I'm going to give myself a minus, maybe a B plus, because I kind of missed the shape a little bit, but I'm really happy with how it came out. But if you'd like to see how to do this, check out this video. I need to make a handle. The main crank, which will go through this, there's a bar that I'll have to make, will have a handle on it. The only other handle is this one. This is for, I think it's for a manual down feed. And so I want to copy the profile of this guy. So I thought that by doing so, what I would do is just take some measurements and then start kind of roughing this out on the lathe. I don't have a template maker for the lathe, but I think with varying degrees of depth, we'll be able to get really close, and I could use a file to bring it home. So let's see what that looks like. So that'll be the end of the handle, but then it'll need to, I'm thinking that it'll have a bolt that screws into it from the back side. Or will this be threaded and it screws into the handle? And if I'm cranking it clockwise, I would be unwinding it if I did that. So would have to tin it, would have to tap it, and then get a pin in there or bolt on the back side. So I definitely don't want to be marking that too short. All right, pretend that didn't happen. So let's think about this. I mean, we'll just give ourselves plenty of room to work. And then that way we can decide. But from an order of operations standpoint, if I did want to thread the end, or if I wanted to tap the end of it, I need to do that in the beginning on this end, because once it's this shape, that won't really work. But I also, if I think about this, I won't be able to fine tune the end. This part is in the vise, or sorry, is in the lathe. I could put this, now I'm just imagining if this piece was standalone, I could mount that on the Bridgeport with some V-blocks on either side to hold it, and then drill and tap. Could do that. I do think that drilling and tapping is the right move, and I'll put a bolt on the other side to hold it in. Okay. We're going to run with that idea. So that's the case. And I'm going to need to give myself a little bit of room to work. So we'll just come to about here. A couple of max diameters. Is we have this, which is 127, 1270. And then we have this. Well, we have a lot, actually, a lot of measurements here. Just over an inch. All right, I think we've got a general idea. Let's bring it over to the lathe and start taking a look at what we can do. That is glorious. Wow. Best initial surface finish ever. Oh boy. It's got, maybe could have slowed it down a little bit, but that looks great. I want to get the outside diameter to 1.25, so 1 1/4. Currently at 134. Let's go 30, 73. Got a lot of stick out. Let's take this 20 and then 15 depth of cut. All right, we're looking for like 126, 127, 127.3, so that's good. I think what I'm going to do here is use you're warm, I'm going to use a parting tool, and I'm going to carve into it kind of discs of the varying dimensions of the piece. But for me to be able to do that, I'm going to need to put a center in the end so I can hold it. And I should have, this will be the other way, but I'm just checking my total distance, because if I put a little center in there, I don't want to end up with a hole when I finish that off this way. So I can put a center in there right now, and then we'll support the end. All right, what I'm doing is I have this piece of paper. It's a 1/4 of an inch for every line. And I've lined up where I want the base to be, and then this high point on this side, which is 1 inch. So at 1/2 inch over, I'm 1 inch in diameter. So then at 3/4 of an inch over, I'm at 0.76. At 1 inch, I'm at 0.65, and at 1 1/4, I'm at 0.65. So I'm just going to keep measuring everywhere it lines up with the paper. That's 1/4 of an inch over, and I'm at 0.69. And then the next one's creeping up. 0.79. And when I'm doing this, I'll have to know 0.9, because the width of the parting tool is like 1/8 of an inch. So I'll have to make sure that I'm on the left or the right side of that measurement as I'm going either up, kind of up the hill or down the hill. I'm not sure this technique would put you on a rocket ship quality, but I have high hopes that it will get us very close. Let's see if we can do it. So here's my setup. I have the measurements, so for every 1/4 of an inch, I know what the diameter should be. And then based on touching off here on 0, I've measured in how deep I need to bring the cross slide in, so it'll be a little bit easier for me to track. I've zeroed out the cross slide, and I've made a mark down here, and it's on 0 on the indicator. And I've also zeroed out my leftmost edge here, and I'll be using the indicator basically 1 inch at a time to bring over the 1/4 inch measurements. And with that, I think we're ready to go. So first cut, we want it to be 0.65, 650 in diameter, which means my depth of cut needs to be 310 from where I'm at, and that's from taking the total diameter of 1.27. Let me do the math again on my calculator. 1.27, which is the current diameter, and I want it to be 0.65, means the total diameter reduction is 620 thousandths. So divide by 2 is 310 thousandths. So my cross slide needs to go in 310. And when that happens, we'll have the right diameter that we need. Let me think. Then the other part is this is going up. We're getting larger. So I think what we'll do so the next mark, which is at right, so I'll be measuring from the right edge of the tool, going over 1/4 of an inch, and then we're going to set that at 0.75. That way we're not carving into the hill. All right, let's go. I've got the speed turned down, not on back gears. I don't think I'll need it for this. We'll check it out. You know, I'm going to slow this down a little bit more too. All right, now that I have the first set of cuts in, I've gone ahead and I've split the difference on all of these. So I'm going to do one more round of cuts to take down the high spots. So I've put in a carbide parting tool, and I've sped up the RPMs just a little bit. I took off the back gears. It's still in low gear, but not the lowest since the back gears are now off. And I'm going to see if I can kind of trim this up by hand without causing too much of a fuss. And let's see how it looks. My intention here is to take out these razor blades. Yeah, that works really well. All right, so what I'm intending to do here is I'm going to come down, cut off these discs, and then sort of split the height difference between the left and the right of them to continue to shape this out. So I left enough of this piece and enough of that main diameter to be the same so that I can drill and tap this hole out. It looks pretty true. I like that. Let's just take this parting tool and take that little nip off. Almost, just a little bit left. Okay. Okay, out. We're going to see, well, my last hope here is that, it's not the last hope, but I'm really hoping that the Scotch-Brite deburring wheel can kind of get rid of some of these ridges. Let's give it a try. It's getting there. Might take a while. I'm going to come back to you here a little bit later after I've made some more progress. So there you have it. Finished handle. You can do this, really any profile. Just kind of use some of the steps that I laid out for this one. And I've got the bolt. It's going to go in there nicely. This guy is ready to go. If you like this video, please give me a like. Feel free to give me a comment. Is there a different way, better way of doing this? I'm all ears. Let me know. And then if you'd like to see more videos like this, please consider subscribing. Thanks a lot. Have a great day.